Okay, chapter 1.5 inequalities. Okay, for the inequalities, okay, when you solve an inequalities, is the method is almost same as the method of solving equations. There's one difference, so let me talk about it. So first of all, as you solve inequalities, you can add any number to each side of the equation, or you can subtract any numbers from each side of the equations. So for example, x minus 4 is less than 5. So in order to find x, you can make this negative 4 0. So by adding 4 to each side of the inequality. So you can add 4 to each side so that x, this one cancel out, so x is less than 9. So this is the solution. So the solution of this inequality is, all the x values that is less than 9. So this one is okay, right? How about multiply? Okay, so here it is 3x, another example. The 3x is less than 12. So in this case, in order to find x, you can make this one 1x, right? 1 times x. So we have x in the left-hand side of the inequality. So when you multiply or divide inequality, you can just multiply or divide in a positive number. So you can multiply or divide each side of the inequality by a positive number. A positive number, then just you don't have to change the symbol. Okay, for example, okay, let me rewrite it. So 3x divided by 12, right? So we're gonna do what? Divide each side of the inequality so that we have only x on one side. Right? So, just like using equations, x, just divide it by a positive number or multiply each side by a positive number. So a positive number, is a standard method, really simple. But the third example is different. So this is the only difference. This is different from solving an equation. So when you divide the inequality in each side of the inequality by a negative number. So when you divide or multiply the inequality by a negative number, always change the direction of the inequality symbol. Change the direction. So reverse the direction of the inequality symbol. So for example, 2x is less than 6. So in this case, I want to divide each side by 2. Each side by 2, right? Each side by 2. Sorry, negative 2. Because I want to get rid of this negative 2. So divide each side of the inequality by 2. Then what do? Always reverse the symbol. Reverse the symbol. Okay, change the direction of the symbol. The inequality symbol. It's really important. Others are all same. So finally, negative 2 cancel out, so x is greater than negative 3. So this is the solution. Can you see it? So when we divide or multiply inequality, each side of the inequality, change the direction of the inequality symbol. All right, then let's try an example. Okay, solve 2x plus 1 is less than 7. Okay, this is an inequality. So in order to find x, move plus 1 to the other side. So we can do minus 1 each side. So 2x is less than 6. Then next, we will divide each side by what? Divide by 2. So 2 is a positive number, so nothing has been changed. So just divide it and then reduce it. So x is less than 3. So this is the solution. X is less than 3. Okay, this means when you draw a number line, this is 0, 1, 2, 3, 4, and negative 1. So the answer will be what? All the x values that is less than 3. So you can use a bold line like this. And then make a circle, open circle on the number 3. Now open circle means 3 is not included. Or you can use parentheses instead. So for example, here is number 9, right? 0, 1, 2, 3, 4. Then you can use a parenthesis. Okay, parenthesis, this is a parenthesis opening towards the left because the x value is on the left. So you can try like this. So you may use either an open circle or open parenthesis. So that the number at the end is not included. Okay, let's try our next example. Okay, B is negative 3x. Look at this. We have a negative 3x. So maybe we will divide the inequality by negative number. Okay, first we need to what? Remove minus 2. So plus 2 each side, just like when you solve an equation. So negative 3x is now less than or equal to 12. And then now we divide each side by what? Negative 3, right? So since we are dividing the inequality by a negative number, what do? Change the direction. So before I write this inequality, I need to reverse the symbol, right? In inequality symbol. Alright, so x equals what now? Cancel out negative 3, so x is greater than or equal to negative 4. So this is the solution. So when you graph this, okay, let me just follow up use the graphing method in the textbook. So here's a 0, 1, negative 1, negative 2, negative 3, negative 4, and so on. So x is greater than negative 4. So in this case, this is negative. Greater than equal to, there's an equal sign, right? Equal sign means negative 4 is included. X equals negative 4 or x is greater than negative 4. So x is negative 4. So negative 4 should be included. So when you include it, you can use an open, dark circle. And then x is right off this number 4, negative 4. So all the way to the right. Okay, or you can use parentheses. So if you want a parenthesis, then it should be like this. Okay. Instead of using the parenthesis, use what? Bracket. Okay, use bracket to represent equation, the equal sign. So negative 4 is included this time. So use a bracket and then open it towards the x direction. Okay. So x is greater than negative 4. So use a bracket and then open it towards to the right. And we use the bracket because what? There's an equal sign, right? Equal sign. Equal sign means negative 4. This number is included. And parentheses, that means 3 is not included. For the letter B, negative 4 is included, so use bracket. Okay, next definition is the compound inequalities. Okay, there are two examples. Okay, the first example on the number line is, okay, the solutions are starting from 1 and this 1 is included and all the way up to 4, but 4 is not included. So this means there are two inequalities are combined. So two inequalities are combined, which means x is greater than or equal to 1. So there are so many x values that is greater than or equal to 1, right? And then also x is less than, it has to be less than 4. And 4 is not included, so there's no equal sign. So this means we gotta use the conjunction and. We gotta use an and. And means it has to be greater than or equal to 1. So if you rewrite it, let me rewrite this one on a number line. So here is 0, 1, 2, 3, 4, 5, 6, and so on. So this means, okay, let me use a different notation. So x is greater than or equal to 1. So I'm going to include this one. Greater than means go all the way to the right. So everything, all the numbers that is right up number 1, including 1. And then and, x is less than 4. Less than 4 means going all the way to the left, right? So here is 4. 4 is not included. And then go all the way to the left. So since we are using the conjunction and, it has to be the overlapped area. The overlapped area is this area, right? This area. So that area indicates starting from number 1 and all the way up to 4. Can you see it? So if a number is between, x is between two numbers, then we use AND. Or you can rewrite it like this. You can rewrite it. X is between what? 1 and 4. So 1 is included, so use equal sign, and 4 is not included, so there's no equal sign. So actually, this one, the original information, this one is equivalent to this. Okay, so AND means find the overlapped area. Okay, find the overlapped area. The overlapped area. Overlapped area. Okay, overlapped area. Okay, then next example is, okay, the x intervals are separated. So x can be either on the left-hand side interval or x can be in the right-hand side of the interval. So in that case, we can write it, x is less than or equal to -1 because -1 is included. And then the interval for the right side is x is greater than 1. So it can be the value of x can lie in either a or in either on the right. So in that case, we used or, okay, or not and. So or means it can be both. It can be either a or on the other side. So it doesn't matter. So it doesn't have to be an overlapped area. So or means put them together. Okay, put them together. But these two intervals are separated. So we need to put them together. So use or. Okay, so in that case, so the graph of, so there are two inequalities, right? Connected with or, and then two inequalities connected with and. So and means find the overlapped area of two inequalities. Or means it can be either interval, right? Either the interval A or interval B. So that means put them together. Okay, so keep in mind this one. Okay, solve these two inequalities. Okay, these two inequalities are connected with or. Okay, or means, okay, let's solve it first and then draw this one in a graph. Graph on the number line. So the first inequality, we can divide each side by 2. So x is less than 5. So we have one inequality, or, okay, the next one is -1 each side. So x is greater than 8. Here's another one. So this one or this one. So if they are separated, then we can put them together. So okay, let's see what happens. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, the first one is x is greater than 5. So x is greater than 5. So put open circle and all the way to, less than, sorry. So less than means go to the left. And the second inequality is starting from 8, but 8 is not included, and all the way go to the right. So can you see it? So two intervals are separated, so that so x can lie in either side of this inequality. So we used or. Okay. All right. And then if we use a set, there's another notation using a set builder. Okay, set builder means we will use a set notation. So set notation is this one. You use the square bracket like this. And then the x values are what? So this means write down the variable x. So it will be, this indicates, okay, x, the solution of these inequalities are all the value of x such that, draw a bar means such that, and explain the value of x. X is what? Less than 5, or x is greater than 5. Greater than 8. So write down those inequalities on the right side of this vertical bar. Okay, so that is the set notation. So we call this one what? Set such that. All right, then let's try this one. So draw this so solve it first. So -3 each side. Then this will be x is greater than 1 and right, and okay, -1 each side, so 2x is greater than 14, and then divide each side, so it will be 7. So we have two inequalities connected with end. So that means we should have what? In a common area. So here is 1, 0, 1, 2, 3, 4, 5, 6, 7. Okay, so let's draw. So x is greater than 1. So x is greater than 1 means go all the way to the right. And then the second inequality is what? X is also greater than 7, right? Okay. X is greater than 7. X is greater than 7. So what's the common area? The common area is the area where the blue and the red parts, right? So this is the common area. And means find the common area, right? So the solution is x is greater than 7. This is the solution. So we can write it as, in our set notation, also we can write the set notation. So the solution will be all the value of x such that x is greater than 7. Okay. Alright, let's try this one. Okay, x is greater than 1 or x is less than 3. Okay, or means, put them together. Okay, put two regions together, two intervals together. So x is greater than 1 means, okay, here is 0, 1, 2, 3, 4, negative 1, so on. Okay, x is greater than 1. So here is 1, and then x is greater. So go all the way to the right. And then x is less than 3. So less than 3 means, here's a 3, and then go all the way to the left. All right. So or means what? Or means put together, right? Put together. Put together. So it contains the red part and the blue part. So actually, it contains everything, right? Everything. So the solution will be all real numbers, all real numbers. So the solution is what? Solution is all real numbers, all real numbers. So we can write it as this one, negative infinity to all the way to positive infinity, right? Okay, can you see what the difference? The difference is, okay, how about another one? So let me make another example. Okay, I want to solve this. Okay, x is now less than 1. Okay, less than 1, and let's use and. X is greater than 3. Okay, so let's draw the graph. Here's a negative 1, 0, 1, 2, 3, 4. So x is less than 1. That means here is 1, and the less than 1. Go all the way to the left. And the other one is what? X is greater than 3. So go all the way to the right. And means what? Common area, right? Common area. Or overlapped area. So is there any overlapped area? No overlap area, right? No overlap area. So that means the solution is, there is no solution. Can you see it? There's no solution because there's no overlap area. Okay. Okay, now let's learn the definition of absolute value inequalities and solve how to solve the absolute value inequalities. Okay, before we do this, what is the absolute value equation? Okay, absolute value equation. Okay, anyway, this one represents what? Absolute value of x is less than 2, right? Or absolute value is equal to 2, right? So in that case, let's find out what the values of x. So absolute value of x is equal to 1. So 2. So how do you find this one? Okay, this one will give you two equations, right? So one is if x is positive, then you get, just remove the absolute value symbol. So you have x equals 2. And the second equation is if x is negative number, what do? Put the negative sign outside the x, so that x equals negative 2, right? So what we did is you can rewrite the equation twice. So one is exactly the same without the absolute value symbol, and the other one is put the negative sign on the right hand side. That's what we did, right? So when you graph it, here's 0, here is 2, and negative 2. So the absolute value of x equals 2 means the x values are 2 and negative 2. Can you see it? So that is the equation, absolute value equation. But for the absolute value inequalities, okay, if the absolute value is less than means what? Okay, this means between. Okay, x is between 2 and negative 2. 2 and what? Negative 2. So you can rewrite it. You can rewrite it as this. X is between 2 and negative 2. So if there's an equal sign, then put the equal sign together. So as you see this, if absolute value is less than or equal to, then what we do? Find when the absolute value x equals 2. Okay, this is 2, right? 2. So this 2 and negative 2 are the solution. Then if that is less than, then means x is between these two numbers. Okay, between these two numbers. So if we graph this one, then here is negative 2, 0, 2. So the solution will be between these two numbers. Okay, between. Can you see it? Okay, so that is example 1. What if x is greater than, absolute value is greater than 2? Okay, now absolute value is greater than 2. All right, then okay, the answer is this. We know the value of x when the absolute value is equal to 2, right? The value of x is negative 2 and 2. Then if absolute value is greater, then the solution is outside this number and outside this number. Okay, outside this number. Can you see it? Not between 2 and negative 2. It's outside 2. So this will give you two inequalities. This will give you how many inequalities? 2 inequalities. Compound inequalities. The first one is x is greater than 2. Or we will use or x is less than what? Negative 2. Okay. You have 2 and negative 2. So always change the sign. One is x is greater than the larger number 2, and when x is greater or less than the smaller number, negative 2. Okay, always. So keep this in mind. So we will apply this property. Okay. So this is so don't forget this. Always we have this and then this. Okay. All right, when we solve this one, this is an absolute value inequality. So, okay, the absolute value is less than 7, right? Less than. That means what? It is between two numbers. So let's say like this. For example, the absolute value is less than 7, right? Then this will give you the star. I don't know the expression inside the absolute value. So the star is less than 7 and greater than what? Negative 7. Okay, automatically like this. So we will write something like this. So 2 minus 3x is what? Less than 7 and greater than what? Negative 7. So always between. So the star is between 7 and negative 7. So from here, let's find x. So we can remove 2 from the center by subtracting 2 from each side. So negative 9 is less than, and then negative 3x less than 5. Now we will divide each side by what? Negative 3x, right? Negative 3. So let's divide each side by negative 3. Okay, before we do this, let me change this one. Because we are dividing each side by negative. What happened? What happened to the inequality symbol? Reverse, right? Reverse. So that is positive 3x and then negative 5 over 3. So let's rewrite it. So write the smaller number to the left, larger number to the right. So we can flip this inequality. So it's much easier to read and look, right? So just flip it, flip, right? Interchange the side. So this is the solution. So once we have the solution, you can graph it. Here is 0, 1, negative 1, this negative 2. So negative 5 over 3 is somewhere over here, right? This is negative 5 over 3. 1 and 2/3. And then 3 is over here. So the solution is where? Between, right? Between this one. So you can write it. There's no equal sign, so put parentheses. Okay, I think I need to make it a parenthesis or open circle. It's gotta be okay. So this part, right? This part is negative 5 over 3. So you can, so starting from negative 5 over 3 all the way to 3. But the endpoints are not included because there's no equal sign. Can you see it? Okay, so please understand the definition. So when you solve absolute value inequalities, make sure whether the absolute value is greater than, less than, or equal to. Also equal to doesn't matter. So less than. If absolute value is less than, like this, then the star is between 7 and negative 7. Always. All right, then let's try letter B. Okay, now absolute value of 4x minus 3 is greater than 5. Now greater than or equal to 5. So if this is greater, then what? The star is outside, right? So here, absolute value of x is greater than 5. Okay, let's say there's equal sign. This means the star, the expression inside the absolute value is what? Greater than or equal to 5, or use or that is outside, right? Outside. The star is less than or equal to what? Negative 5. So one is positive 5, one is negative 5. And that is outside. So you can rewrite it. So this will give you 2, right? So this will give you 2 inequalities. One is 4x minus 3 is greater than or equal to 5, right? Or 4x minus 3 is less than or equal to what? Negative 5. Okay, then let's solve each inequality. So plus 3 each side. So 4x is greater than or equal to 8. Divide each side by 4. So x is greater than or equal to 2. Or means, put together, right? So plus 3 plus 3. Then 4x is less than or equal to negative 2. And then divide 4 each side. So negative 2 over 4, which is x is less than or equal to negative 1/2. Okay, so these two are the solutions. So when you graph this one on the number line, here is 0, 1, 2, 3, and negative 1, negative 2, and so on. So this part is negative 1 over 2, right? So let's graph it. X is greater than 2. So here is 2, and then 2 is included because there's equal sign. Go all the way to the right. And then for this one, negative 1 is over here. So put them together, there's equal sign. So make it a dark circle and then go left. So that's it, huh? That's it. So since this is OR, the answer will be these two regions, two intervals. So when we write an inequality solution, we can write the solutions in three different ways. One is an inequality symbol. Use the inequality symbol like this, x is greater than or x is less than something. And then also we can use a graphic notation or we can use interval notation. So interval notation is really simple. So starting for this example, there are two intervals. So one is on the left. So the numbers are going all the way from the left-hand side, so which is negative infinity. Right? Negative infinity. And then all the way up to negative 1 over 2. So in that case, we use, if the end point is included, then we use a bracket. Use the bracket. So bracket means this end point is included. So negative 1 over 2. And then the interval on the right is starting from number 2 and go all the way to the right, which is infinity, positive infinity. So since 2 is included, use the bracket, opening bracket. And then the infinity symbol is always parenthesis. So negative infinity is also parenthesis. Okay, how about A? The problem A is this one. Okay, the interval is between 2 points, right? So 2 points, then we can use the interval notation like this. So negative 5 over 3. So this number is not included, so put parentheses and then comma, followed by the number on the right. Like this. So since 3 is not included, also use the parentheses. If you scroll it up, okay, for the interval notation on this part is what? X is less than negative 2. So all the way to the left, from the left. So negative infinity with the parentheses, comma, going all the way to the right, which is negative 2. And negative 2 is not included, so use parentheses. Okay, there is also, we are putting these two intervals together. See, we use the OR, right? OR. So in case of you, if you are using OR, the symbol for OR is U, okay, U shape. So U shape is like a cup. You have a cup so that you can put everything inside the cup. So use the union symbol, U, that represent OR. And then starting number 2 is not included, all the way to the right, positive infinity. Okay, how about this notation? Okay, this notation is between 2 points. So starting from negative 2 to positive 2. And negative 2 is included, so put parenthesis, bracket. And the positive 2 is included, so put bracket. Okay, how about this one? Okay, this one is just negative 2 and 2, right? So we don't need inequality intervals, so never mind. All right, can you see how we write the inequalities in 3 different ways? One is using inequality symbol. The second part is use the graphic notation. And third one is use interval notation. Or you can use a set notation too. So set notation is simple, as we see in the above. Okay, set notation is this one. So use a square bracket. Okay, square bracket, and then write down the variable x that represent the solution, and then draw the vertical line and then write the inequalities. So very simple. This is called set notation. Okay, next example is solving a polynomial inequality. Okay, find the solution set of this inequality and then write the answer in interval notation. Okay, this means, okay, before we solve this one, let's think about a graph. So let's say here is a graph, something like this. Here's a graph, and this is the x-axis. And then let's say y-axis is somewhere. Let's say this is the y-axis. Then as you see this part, the graph of a function, let's say this is y, this is an f of x. So this, the graph of a function looks like this. Then this graph crosses the crosses the x-axis, and we call this x-intercept, right? We call these points x-intercept. So based on this x-intercept, the graph is either positive or negative. If the x-intercept indicates that the x value is 0, right? I'm sorry, the y value is equal to 0. Sorry. That means the y value equals 0. The y coordinate of each point is 0. Right? So based on this x-intercept, the graph is either positive. So this graph has positive y values, and below the x-axis has negative y values, right? And this is the positive y values, and this area has negative x values. So depending on the x values, based on the x-intercept. So if let's say this x is -1, sorry, this is -2, -1, 0, and this is 1. Okay, then if x is less than -2, then the y value is negative, right? Negative. The y value is negative. If x is between -2 and -1, between these 2 points, then the y value is positive, right? And then if the x interval is -1 to 1, then the y value is negative. As you go to the right from number 1, then the y value is positive. So based on the x-axis, based on the x-intercept, let's say this is x-intercept, -1. Let's say this is 1. Then okay, also -2, -2. Okay. So we can say something like this. So when x is negative, so these are the x-intercept. Then makes the when y equals 0, then these are the points x-intercept, right? So if the interval is this, then the y value is negative. If the interval is between these two, okay, let me just repeat it. The y value is positive. If the x-intercept between -1, 1, then the y values are negative. Again, if x is greater than 1, then the y value is positive, right? So based on the x-intercept, each interval is either positive or negative. So the y values for each interval is negative or positive. So using this information, why don't we let this inequality equal to 0? Make this value equal to 0. So we can say that this expression is function y, right? Function y. So when we graph this guy, then the graph will be something like this, this graph, something like this. So this graph crosses the x-axis, and that x-axis is, the x-axis are, I'm sorry, not, so those points on the x-axis are what? The x-intercept, right? So we want to find x-intercept. So find x-intercept first. Find the x-intercept. Okay, so how do you find the x-intercept? Set that the y value equal to 0, right? So set the expression equal to 0. Then from this, let's factor these 4 terms. Then maybe we can use grouping. Okay, let's make a grouping. Use the grouping. So x, factor out x from these first 2 terms. Then we have x plus 3. And then for the second group, factor out -4. Then it will be x plus 3 equals 0. So here are binomial terms, right? Binomial terms are the same. So this is the common factor. So factor this x plus 3. Then we have x minus 4 equals 0. I'm sorry. Okay, so actually, I copied the wrong information. This is x cubed, right? X cubed. So in that case, factor out x. this x cubed, and this is x squared. Oh, I'm so sorry about this one. This is x squared, right? So factor out x squared. Then it makes more sense. X squared, that this is x plus 3, and this will be x squared, right? X squared minus 4. Still, we can factor it again because the second binomial factor is difference of squares, right? Do you remember? A squared minus b squared can be factored as a plus b, a minus b, right? So this will be x plus 2 and x minus 2 equals 0. So from here, set each factor equal to 0, set each factor equals 0, then the solutions are x equals negative 3, negative 2, and 2, right? So based on this, these x values are the x-intercepts. So these are the what? X-intercepts, right? So the second step is plot x-intercept. So here it is negative 3, this is negative 3, and this one is negative 2, and this is positive 2. Okay, the inequality contains equal sign. Equal sign means the x-intercept is included, right? X-intercept is included. So I'm gonna put a dark circle. So dark circle represents these x-intercepts are included. All right, and then so as you see this one, these 3 points divide the x number line x into 4 intervals. 4 intervals, right? Less than negative 3, between negative 3 and 2, negative 2, and between negative 2 and 2, and greater than 2. So there are 4 intervals. So for each interval, we want to find whether the graph is positive or negative. Okay, so why don't we plug in any value that is less than negative 3? So let's try negative 4. Okay, negative 4. So, okay, let's use negative 4. Let's use the factor form. So x plus 3, x plus 2, x minus 2. So this function must be greater than or equal to 0, right? That's given from the original equation. So when we plug in negative 4, what happens? If x equals negative 4, then this will be negative, right? Negative times negative times negative 4 minus 2 is negative, right? So the product is, there are 3 negatives, so when you multiply 3 negatives, it becomes negative. So when x is less than negative 3, the y value is negative. Okay, how about an x value that's between negative 3 and 2? So why don't we try negative 2.5? Okay, 2.5. Then negative 2.5. Once you plug in negative 2.5, the first factor will be a positive. The second factor will be negative, and third will be negative. So product of these signs will be negative. Oh, sorry. Negative. Okay, that's positive. Okay, plug in negative 2.5, so it's negative. So negative. So the result will be positive. Okay, and then if x is between negative 2 and 2, so let's use 0. Okay, let's use x equals 0. Then 0 plus 3 is positive, 0 plus 2 is positive, 0 minus 2 is negative. So multiplying these 3 signs will be a negative. Okay, let's try one more. X is greater than 2, so let's use x equals 3. Then 3 plus 3 is positive, 3 plus 2 is positive, and 3 minus 3 is also positive. So product of these 3 positive numbers is positive. So can you see this one? So we don't know how the graph look like, but actually we know, at least we know whether y is positive or negative. So since the expression is greater than or equal to 0, this means positive, right? The graph should be, so we are looking for the interval where the y value is positive. this is positive. Okay, this means positive, right? Positive. Because this expression is greater than 0. So the positive is this area, isn't it? This area. Right, this area. So including the end point all the way to this one. So the solution. So this interval contains positive y values. So these are the solutions. So therefore, when x is between -3 and -2, or x is greater than or equal to 2, then the graph is positive. So we can write in interval notation. So negative, starting from -3, and the endpoints are included. Or means use the union symbol, and that's greater than or equal to 2. So 2 all the way to infinity. Okay, so these are the solutions. So can you see how we did it? So what you have to do is make sure you move all the terms to the left, so the right side is 0. So the expression on the left-hand side of the inequality should be equal to 0, so that we can find the x-intercept. So once you find the x-intercept, what do? Check each interval whether the y values are positive or negative. If the y values is positive, then those x intervals are the solutions in this case. So if the expression is less than 0, that means negative, right? So in that case, we are looking for the negative, we are looking for the interval where the y values are negative. But in this case, y values are positive. So look for the interval where the y values are positive. Then they are the solutions. Okay, let me summarize these ones again. So first, we need to find the x-intercept. Okay, the x-intercepts are sometimes called the critical numbers, critical values. Critical values. Okay, so find the x-intercept. And then once you find the x-intercept, make sure you write on the number line, mark the x-intercept, and therefore, based on this x-intercept, there are x intervals. So for each interval, find the sign of y. Can find the sign of y, whether the y is positive or negative. So mark plus for the positive y. This means for positive y values. The negative means negative y values, right? Y value. Okay, so once you mark plus or minus, then check the original inequality. If the inequality is greater than 0, that means we are looking for the positive y. So the answer will be the x-intercept that has positive sign. Okay, otherwise, the solution will be those x-intercept that has negative sign. And then also, if the inequality contains equal sign, then make sure the x-intercepts are also included in the solution. Okay, so we can write the answer in inequality notation like this, or interval notation like this. Okay, let me try another example similar to this one. Okay, so I want to solve this inequality. So first step is what? Set the inequality equals what? 0. So we want to find the x-intercept. Okay, find the x-intercept. So we can factor this one. So x times x, 4 is 1 times 4, and negative sign goes here. So this product is negative x, this product is 4x, and the sum is 3x. So we can factor this trinomial. So the trinomial is the product of x minus 1 and x plus 4 equals 0. So the x-intercepts are what? So x-intercepts are 1 and negative 4. So once we find the x-intercept, so these are the x-intercepts, right? X-intercepts. Then plot these points on the number line x. So this is 1 and negative 4. So these 2 points separate the x-intercept into 3 intervals, right? 3 intervals. And then as you see this, the inequality does not contain what? Equal sign. So the endpoint, the x-intercepts are not included in the solution. So I will put open circle. So open circle means these x-intercepts are not included. All right, then from this, for each intersection, in intervals, we will find whether the expression, the polynomial is positive or negative. So let's plug in here. So for x equals, let's say, okay, any number that is less than -4. So let's use -5. So for this one, let's check whether, okay, so this is the factored inequality, right? The original one was not factored, but now we factored it. So from this, let's find whether the polynomial is positive or negative. So plug in -5, then this will be negative sign. And -5 plus 4 is negative sign. So multiplying these two is positive. So this part is positive. How about x between -4 and 1? So let's try 0. So once you plug in 0, then the left hand, the first factor is negative. Okay, x plus 4. So 0 plus 4 is positive. Then the product is negative. Okay, let's try one more. If x is greater than 1, then let's try 2, right? 2. Then 2 minus 1 is positive. 2 plus 2 is positive. So multiplying these two signs will be positive. So in this case, what are we looking for? The less than 0, right? Less than 0. So that means we are looking for the negative sign. And negative sign. So which one has the negative sign? The interval in the middle. So x has to be greater than -4 and less than 1. Therefore, the solution set is what? The solutions are x is greater than -4 and less than 1. Do we need to put equal sign? No, because the x-intercept is not included. Or you can write it in interval notation as -4 to 1. And these endpoints are not included, so we'll use what? Parentheses. Okay, can you see how we did it? Okay, then let's try finding inequality that has rational expression, rational. Okay, now next example is solving a rational inequality. So this is an inequality that contains a rational expression. So rational means a fraction, and the fraction contains variable in the denominator. So when we have an equation, always move all the terms to the left and make sure the right side of the inequality is 0. So move 2 from the right to the left. So it will be -2. Then once we have this on the left hand side, we can make it one fraction. So if we rewrite it, it looks like this. So the denominator, this is over 1, right? So we can make a same denominator, x plus 1. So the numerator must be multiplied by x plus 1. Okay, then the numerator will be, so using the same denominator, x plus 1. Let's rewrite the numerator. So 3x minus 4. And this one, you multiply x by -2, right? So minus 2x. Multiply this by -2 as well. So it will be -2. Can you see this one? All right, so this 2 will be, this is 2 is a factor with the negative sign. So -2 is a factor. All right, then simplify the numerator. So x minus, is it plus 4? Okay, sorry, this is plus 4, right? Plus 4. So that is x plus 2 over x plus 1 is less than or equal to 0. Now, this is so we just simplify the left-hand side. So we have only one fraction, rational expression on the left side of the inequality. Okay, so from here, the first step is we're going to find the critical values. Okay, critical values means if the numerator is 0, then what happens? If the numerator is 0, let's say here is x. X over, let's say x over 2. Then if the numerator is 0, then the value is 0, right? 0. 0 means the y value is 0. Since y is 0, then we call this x-intercept, right? X-intercept. Because let's say y equals this one. And if x equals 0, then the result is 0, which means y equals 0. So that means there are some value x, then y is 0. This is the x-intercept, isn't it? So when you set the numerator equal to 0, and all those x values are the x-intercept. X-intercepts. Okay, so y equals 0, that means those x values are what? X-intercepts. Okay, and then also we can set the denominator equal to 0. That means if the denominator is 0, what happens? Like 1 over x. So if x equals 0, then what happens? This is undefined, right? So undefined means when this part is 0, then there's no y value. It's a vertical asymptote. We call it a vertical asymptote, but actually there's no x value, right? No x value. No y value. So if there's an equal sign, then equal sign means the y is equal to 0, right? Y is equal to 0. Y equals equal to 0 means the x value will be coming from the numerator. Because if the numerator is 0, then y is 0, right? So that's the x-intercept. So in this case, set the numerator equal to 0. That means x equals what? -2. So this is the x-intercept. X-intercept. So if there's equal sign, then we will include this x-intercept in the solution. And also set the denominator 0. So the denominator is this one, right? So set the denominator equal to 0, then x equals -1. That means this is undefined, right? Undefined. Y is undefined. Right? Y is undefined. That means no matter whether there's equal sign, we don't include. Okay, do not include. Always do not include this value, right? This value in the solution. Always. Okay, and this x-intercept included, right? Included when there is the equal sign in the inequality. Make sense? Okay, now next step is plot these 2 points on the number line. So when x equals -2 and -1. When x equals -2, that is the x-intercept, right? So since there is equal sign, we're going to include this point. So I will put a dark circle. And then when x is -1, that's undefined. So undefined, always do not include this number. So -1 is not included in the solution. So there are three x intervals. So interval 1, interval 2, and interval 3. So for each interval, let's find whether the y is positive or negative. Okay, so for the interval 1, let's find whether it's positive. So let's use x equals -3, because -3 is within less than -2, right? So okay, the expression is x plus 2 over x plus 1. This one should be less than or equal to 0. So if x is -3, then the numerator will be -3 plus 2. That is negative, right? Negative over -3 plus 1 is negative. So negative times negative divided by negative is what? The result is positive, right? So for this interval, the y value is positive. How about 2? Let's use x equals, okay, between -2 and -1, so y normal is -1.5. Okay, -1.5. Then the numerator will be 1.5 plus 2 is positive, right? Positive. And the denominator is negative. So the result is negative. So for this interval, the y value is always negative. Okay, let's try one more. Okay, if x is greater than negative 1, so why don't we let x equal 0? Then if x equals 0, then 0 plus 2, the numerator is positive. The denominator is also positive. So the result is positive, right? So for this interval, the result is positive, so y value is positive. Okay, so for this, all for these three intervals, they have different signs of y values. We are looking for the interval where the y value is less than, right? Less than or equal to 0. Less than 0 means negative part. So which one is the negative part? This one. So this interval contains negative y values. And then also there's equal sign. Equal sign means we're going to include the x-intercept. And x-intercept comes only from the numerator. Comes from the numerator, right? And then how about negative 1? Negative 1 comes from the denominator. If the denominator is 0, then there's no y value. No y value, so negative 1 is not included. So therefore, what's the solution? So the solution is this inequality. X has to be greater than or equal to 2 and less than negative 1. And 2 is included, so there's equal sign. Negative 1 is not included, so there's no equal sign. In interval notation, you can write it bracket 2 all the way up to negative 1 and then close parenthesis. Okay, next example is an application example. Okay, there are two machines, copy machines. So machine A costs $75 per month, plus whenever you have a copy, then you pay 5 cents. Okay, machine B costs $210 per month, and then when you copy, you pay what? 2 cents per copy. Then find how many copies does machine B needs. So that the machine B is less expensive than machine A. So why don't we write two expressions using inequality? So the machine B, the total cost for machine B is $210 plus 2 cents per copy. So let's say you make X copies, X number of copies, then there will be 2 cents is $0.02, right? So this 2 cents times number of copies. So this is the total amount of machine B. So this machine B will become less than what? The total cost of using machine A, which is 75 plus 5 cents per copy, so 0.05. How many copies? X copies, right? So this is the inequality. So from this inequality, let's find X. All right, then let's move all the X terms to the left. So minus 0.05X from each side, 0.05X. Then this will be 210 minus 0.03X is less than 75. And then move 210 to the other side. So negative 210, negative 210. Then negative 0.03X is less than, that is negative 135, right? Okay. Then we divide each side by negative. So I want to divide the left-hand side by negative. Then what happens to the symbol? Change the direction. So negative 35 over negative 0.03. Then the left-hand side is X. So X is greater than what? So the positive 135. Sorry, this is 135. Okay, so this will be 4,500. So if you make more than 4,500 copies, then the machine B will be cheaper, right? So in this case, this is not hard. write an inequality. So write the expression correctly, and then write inequality, and then solve for the variable. Okay, another application question. The average should be greater than or equal to 72 and less than 82 to get a grade C. So the average should be between 72 and 82, but 72 is included. Okay, the first two scores are 70 and 81. Then what should be the third score? All right, then the average is, how do we get the average? Okay, find the total of all 3 points. So let's say the third score is X. So we have 3 scores, right? Sum of these 3 scores and then divide by 3. So this is the average, right? Average. So this average has to be greater than or equal to 72. And then less than 82. So we have a double inequality, right? So from this one, let's find X. All right, so let's remove the denominator first to find X. So we're gonna leave X in the center, so that we have to remove all the other terms. So let's remove 3. So how do we remove it? Multiply each 3 parts, each part in this inequality by 3. So 72 times 3 is 216. And then the center, in the middle of this one, so multiply this expression by 3 means 3 cancel out. So we have 70 plus 81 plus X. Less than, so 80 times 3 is 246. Okay, now 70 and 70 plus 81. So make a sum of these two numbers, which is 151 plus X is less than 246. Okay, now we can leave X, so that remove 151. So what we do is subtract 151 from each side, each part. So minus 151 here, minus 151, minus 151. So that will be 65 less than or equal to X, and then 95. So if this student get 65 or less than 95, then she can get grade C. So, or we can write it like this. The interval notation is starting from 65, but this one is included. And then 95 is not included. So it has to be less than 95. Then the grade will be C. Okay, one last example. Okay, a company is manufacturing and sell in X units. So when you manufacture X units and sell those all X units, then the cost will be 30. The equations are given. So the cost equation is 32X plus $120,000. And then when you sell this product, the revenue will be X times 200 minus 0.01X. Then how many units should be manufactured and then sold to have a profit of at least 500,000? So if you want to have a profit, then how do you find the profit? Okay, here's the profit. Okay, let me solve it. So the profit is, how do you get the profit? The profit is the total revenue minus the total costs, right? And already the revenue and the costs are given. So the revenue is X times 200 minus 0.01X. And the total cost is 32X plus 120,000. So let's simplify this one. Then this will be 200X distribute, right? So negative 0.01X squared minus 32X plus 120,000. Then combine the like terms. So let's write the X squared term first. And then 200 minus 32X is plus 168X minus 120,000. So this is the expression for the profit. So the profit, the question is the profit has to be at least, right? At least $500,000. That means at least means greater than or equal to, right? The minimum value is 500. So it's got to be, the profit has to be 500 or more. So based on this information, let's write this expression, replace this expression for the profit. So we can write it like this. Negative 0.01x squared plus 168x minus 120,000 should be greater than or equal to 500,000. And then solve for x. So move 500,000 to the left. Then we get negative 0.01x squared plus 168x. And then minus 500,000 is minus $620,000. So that is greater than or equal to 0. So from here, well, you can use why don't we use a quadratic formula? Remember quadratic formula? Okay, the quadratic formula is what? X is negative b plus or minus square root of b squared minus 4ac. C is negative 620,000. And then divided by 2a, right? 2a. 2 times a. Okay, so that would be negative b, right? So what's the formula again? Okay, let me write it. The formula is negative b plus or minus square root of b squared minus 4ac over 2a, right? And then this will give you two values. X is 5,473. Well, 0.3, and x equals 11,325.7. So since this is greater than or equal to 0, and the interval is between these two. Okay, so if you graph it like this, there are two values, right? A and B. Then the interval is, so in order for this to make greater than 0, there should be this interval. Okay, this interval. All right. So the solution is between these two numbers. So it's gotta be, so the company, so it has to be, the number, the units has to be integer, right? Integer. So anyway, if you write it, it's gonna be including these two numbers. But since it has to be a integer units are integers, so it has to be 5,473 or 4. Is it 3 or 4? Sorry, this is, I think I wrote it incorrectly. This is 4. Okay, this is 4. Okay, this is 74.3. Okay, so it has to be a number, right? Number, so that has to be greater than 500,000. So the minimum number should be 5,475, and then all the way up to 11,325 or 6. It's gotta be 25, right? Because it has to be between these two numbers, right? Between these two numbers. Okay. So if x is between these two numbers, then the profit will be at least $500,000. Okay, I hope you understand this chapter. So it's getting tough, right? But once you know how to solve the inequality, the method, find the critical values, and then find the x-intercepts, and then plot those x-intercepts in the number line, and then for each interval, find the sign of each sign of y values, then that's how you can find the solution. So please practice. Okay, do the homework so that you know how to solve this kind of inequalities.